Thanks so much for clicking this video and welcome to Integral of Symmetry. Integral of Symmetry is a new method in order to calculate any primitive of any function in any dimensional space. And in this video we are going to start with the simplest function in the simplest coordinate system. We are talking about the identity function f ds equal y equal s. That function has the following representation in a Cartesian coordinate system, which is just like a straight line with a slot. F ds equal s. And the way that we are going to calculate the primitive of that identity function is by using the area under the curve, which is representative of the primitive of that function. And the way that we are going to use to calculate that area is by the concept of physics called symmetry. Symmetry is a property that some object had that we can change the position and have the same figure that are indistinguishable between them. For example, if we have this square is representative of this coordinate system, the plane of this coordinate system. If we change the position of this coordinate system in a term 360 degrees, we are going to have the same figure 4 times that are distinguishable between them. And unless, of course, if we put a mark, we can now obtain 4 different figures, and we can recognize what is the original position. Then, in order to know what is the symmetry of the identity function, we are going to help by this another figure, which is a triangle. This triangle has the same slot on this figure of this straight line, and we are going to study what is the symmetry of this triangle, which is the same straight line of identity function. Now, if we take another triangle of the same size, exactly the same, and we complete the square, we can have another figure which is no longer symmetry 4. Now, when we turn it, we can know that the symmetry of that new figure is no longer 4, is 2 now. For we have the same figure 2 times because the line in mid of it break the former symmetry. Then this allows us to know what is the symmetry of that curve. The symmetry of that curve is 2, just like the symmetry of the triangle into the square, into the coordinate system, because the square represents the coordinate system. This symmetry of the triangle is going to be 2. Of course, if we can say and we can see the triangle is contained by the square 2 times, and we can say the area of the triangle is the middle of the square. But in the vocabulary of the integral of symmetry, we are not saying that anymore. We are going to say that the area of the triangle is going to be the area of the square divided by the symmetry. That is to say, integral of s ds is equal the area of the square divided by the symmetry of that identity function. That symmetry we have shown is 2, and the area of the square, this is our our x-axis and our y-axis, and we draw a little square. This area is calculated by the width, which is s, the distance from this to this, and the height, which is y, which is s, because it's our identity function fds. Now we had s times s, which result in s to the square divided by 2 plus some constants of integration. Now, in this point, we are going to add another principle of the integral of symmetry that we are going to call hypothesis of the integral of symmetry. That hypothesis states that the new function, or any power of the identity function, that new function, which is going to have the following shape, is no longer a straight line, it's a curve. The function f ds equal s to m. That function had a symmetry into the square, which is the representative of the coordinate system, and the hypothesis of integral of symmetry states that the symmetry of this power of the identity function increase the same quantity that the power increase. That is said, integral of s to m ds is equal to area of the square divided by the new symmetry, we are going to call s prime, is equal, and that symmetry is the former symmetry of the identity function f ds equal s, which is 2, plus the increment of symmetry. What is the increment of the symmetry? The increment of the power. What is the increment of the power? From 1, which corresponds to the identity function, to m, where m is any real number. And we have the increment is going to be m minus 1. M minus 1. And the area of the square is the same with s times the height, which no longer s, but s to m. Maybe it's no longer a square, maybe a rectangle. And we have s times s to m, which result in s to m plus 1 divided 2 minus 1, which is 1. It result m plus 1 in the numerator, in the denominator, plus some constant on integration. Well, in the next video, we are going to use the same procedure in order to calculate our first primitive in three-dimensional space of the identity function of three-dimensional space, which are talking about f ds y equal z equal s plus y. This is going to be our first identity function in three-dimensional space. We are going to replace the square by the cube, which is three-dimensional coordinate system, and the triangle is going to be replaced by this prism. And we are going to obtain the primitive of this identity function and the primitive us any power of this identity function in three-dimensional space. Thank you for viewing this video, and I want to see you in the next.